SI unit of amplitude. What is the SI unit of amplitude?
Meter.
Meter, yes. And what is wavelength?
The distance from crest to crest or trough to trough.
Yeah. So it is one of the definitions. You have another definition. What is that?
The distance traveled by a wave horizontally in the direction of propagation for a complete cycle.
Very good. So, what is the unit of wavelength?
Unit. Meter.
Meter. And what is frequency?
The number of complete waves per unit time.
Number of complete waves per unit time. So what is the unit of frequency?
Hertz
Hertz.
or per second.
Per second. Very good. Walaikum salam. Mahi, why are you late?
Sir, I yesterday slept late.
Okay, so be on time, yeah? Try to be on time.
Okay.
Because you missed some discussion. You have to be on time to take part in discussion, right? Because we are recapping the ideas we learned in last week. It's 1 week back, right? So
Yes, sir.
if we don't recap, we might not be able to get it. Okay, the next thing is coming. So what is called wavefront, Mahi?
Oh, sir.
Yes.
So a surface containing points affecting in the same way by a wave at a given time.
So we got two definitions, right?
Yes, sir.
You learned this one
Yes.
because this is easier, right?
Yes, sir.
So it's fine. But are you seeing the notes and then you are saying?
Yes, sir.
You did not memorize it.
No.
Okay. So next time I ask you, maybe next week I will ask you again. That time you tell me the answer without seeing. Okay.
Okay, sir.
By this time you learn. Okay. Now we have learned two types of waves at the beginning. Mainly the waves are defined or separated in two types. That is mechanical and non-mechanical waves, right? You remember that at the beginning of
Yes,
this
sir.
topic we discussed mechanical and non-mechanical waves. So Mahi, you give me example of mechanical waves.
Water waves
Mm-hmm.
and sound waves.
Very good. So why these waves are called mechanical waves?
So because the energy is transferred by the vibration of the particles.
Yes. So we require medium, right? For this mechanical wave to transfer energy, we need medium.
Yes,
Isn't
sir.
it? And non-mechanical waves example?
Sir, all the electromagnetic waves
Yes,
and light waves.
light waves. So today, when this topic will be over, today we are going to over this topic. So I want you both to send me the notes you wrote in your record copy in scanned PDF format in
Yes, sir.
physicsmaniabd.com. Okay, physicsmaniabd.gmail at gmail.com. Is it clear?
Yes, sir.
Yes, sir.
That email address. I want your work, your notes in PDF format. Okay, by
Okay.
by afternoon you'll send me the work. Okay, now transverse and longitudinal waves. We have other two types of waves depending on the particle's vibration and the energy transfer direction, right? So what are these two types? The direction of vibrations and energy transfer direction, depending on these, we have other two types of waves. What are those two types?
Sir, crest and trough.
No. Monica, what are the two types? Monica, are you there?
Sir, can you repeat the question?
The question is, depending upon the particle's vibration and energy transfer direction, we have two other types of waves. What are those waves?
Transverse wave and longitudinal wave.
Very good, very good. So they are, having this difference, name in their name and action, depending on particles vibration, right? And energy transfer direction. Okay, so what is called longitudinal wave? So, Mahe, what is called longitudinal wave? Hello, we did it, right?
Sir, lightning.
Last week we did it, right? We also gave you the examples, isn't it? Mahi?
Sir, longitudinal waves.
Say,
Iron.
mhm, mhm.
The longitudinal waves that goes parallel to the wave direction.
We forgot. That is longitudinal wave.
Yes,
That's why you are taking long time.
yes, sir.
So what are the examples of longitudinal wave?
Oh, so I don't know examples.
Did I give you examples?
Yeah.
Monica, did I give you examples? Longitudinal wave?
Yes, sir.
Yeah,
Yes,
tell
sir.
us the examples.
Sound sound waves, ultrasound waves, and seismic P waves.
Hmm. Very good. So why they are called longitudinal wave?
Because the vibration of a particle is parallel with the direction of energy transferred in a wave.
Okay, so what do you think? This way I'm asking you, it is good for you or not good? Mahi?
Good.
Good for
Good.
all.
Why it is
Good.
good?
It will
It can
help us
help us
learn.
recover.
So in our next class, I think you already got the message. I will ask you this way. Sometimes I will ask you the previous lessons knowledge, right? Learning of
Yes, sir.
previous lessons. So you always be on your toes. Okay, revise,
Okay.
learn, revise, and be on your toes. Do you understand what is called be on your toes? Hmm?
Yes, sir.
Always get ready, yeah? Always be prepared. Okay, now transverse waves. Monica, what is transverse wave?
When the direction of energy, sorry, wait. When the particle in a wave, sorry, in a wave of particle with the direction of energy transferred.
Hmm, very good. So these classes actually going on Saturday morning. These are makeup classes, right? Isn't it?
Yes, sir.
And our regular class, we are doing which topic now? Which topic we are doing now
Light,
in our regular classes?
light, no, sorry,
Li-
prism,
Yeah, light
dispersion,
is done. Now we are doing
dispersion of light by
yes,
prism.
dispersion of light and electromagnetic spectrum, right? That
Yes,
one we
Yes,
are
sir.
doing. So this is topic 13 of waves. Waves we have four topics. We are done topic 14. That is light. That is the biggest one. And we finished topic 15. That is dispersion of light and electromagnetic spectrum. The theory part we are done, right? Isn't it? And it was very
Yes,
small.
sir.
yes,
You already understood that how bigger was topic light was. Topic 14 light was. So if you uh, combine topic 13, topic 15, and topic 16 together, altogether they are equal to topic 14 light. Is it clear to you? And in your section 4 waves, we have these four topics from waves. Is it clear? Topic 13 is now general wave properties. Topic 14 light you did. Topic 15 also we did the theory part, that is electromagnetic spectrum. And topic 16 is on sound, only on sound. So when we are doing, we are trying to have the revision, right? So that everything is on our mind, we can make a plan for O level. And we are directly learning from learning outcomes of CI. We are following the syllabus of Cambridge. Is it clear to you?
Yes, sir.
yes,
So be up to date and also you track. Yeah, you track that how much of the syllabus is done and how much of the syllabus is left, which learning outcomes are done, which learning outcomes only are left, not only for physics, for all the subjects. The way I am showing you in physics, this is also helping you to get prepared for other subjects. Is it clear?
Yes, sir.
So use this opportunity, the one you learned. We had here reflection and refraction also in last class, right? Can you remember we were doing
Yes.
refraction and you wrote some of the information from refraction. Uh, this one you just give me feedback that how much is done from here, refraction. Did you write the definition?
Yes, sir.
Okay. So refraction means bending of wave, right? For any reason, if there is bending of wave, that is called refraction. Here, we are getting the bending of wave in water. The diagram you are getting here is the bending in water. In topic 14, we learned how there is bending of light. When light is traveling from one medium to another transparent medium at an angle, that time it bends, right? That is called refraction of light. So here we are having deep water and shallow water, right? Isn't it?
Yes, sir.
So
Yes, sir.
when there is deep water, we see the gaps between the wavefronts. The gap is larger, right? And when it is shallow region, the gap between the wavefronts, that is smaller. And we told you a very important thing in last class. I'm repeating that one because it's very, very important, not only for this topic, for other topics coming also. We have this formula, right? V equals F lambda.
Yes.
So beside your diagram, you write this V equals F lambda. If you already wrote, then not necessary. But if you did not write, then you have to write. You draw this diagram. For refraction, we are having some discussion here. This one, frequency. Frequency for the same source, the same source is always same. Is it clear?
Yes, sir.
For the same source, this frequency is always same. I show it from down, that is better. Okay. Now, what is happening here? Again repeating. I already told you, again I'm repeating. When it travels from deep to shallow region, then what happens? Speed decreases, right?
Mm-hmm.
Mm-hmm. I'm writing here. When water wave travels from deep to shallow, region. Speed decreases. Just memorize it. You have to memorize it. Never do mistake. Okay. When water
Okay,
wave
sir.
travels from deep to shallow region, speed decreases. Now, if you focus in this formula, your frequency is constant, right? Frequency is constant, speed decreases. Then what will happen to wavelength? Huh? Hence, wavelength decreases. I can give you one numerical example to understand it better. Like, if you are having uh, like speed, for example, the speed is 10. How much the speed?
10.
10. Then your frequency is 2. How much is the frequency? 2. Then your wavelength is how much now? If your speed is 10, frequency is 2, then how much will be the wavelength?
Sir, 5.
5. Very good. Now, if I say your frequency is constant, that is 2, but the speed is now 8, what will be your wavelength?
Sir, 4.
4. So you got the proof of this statement?
Yes, sir.
Is it clear?
Yes, sir.
Okay, very good. Now, Monica, you take the snap of this part and send it to our group. Okay, with this diagram, with this writing, and my writing. You take the snap. Have you sent?
Yes, sir.
Very good. So we are done with this part, refraction. Uh, are you done with drawing and writing, both of you? Hello?
Sir, no. I'm not done.
Yeah, do it fast. Do it fast. So, do you understand one thing, that if you are attending in classes, then you are getting something more than your notes. And attending in class is important, right?
Yes,
Yes,
sir.
sir.
Because many things maybe you are getting in notes, that one also you are not understanding until you get the explanation from your teacher, isn't it?
Mm.
Yes, sir.
In your Google Classroom, we uploaded the syllabus. We suggest you to download the syllabus and preserve in your device. Which device you are frequently using, that device you preserve it and go through. Go through once in a week or twice, or in 2 weeks, fortnightly you go once, okay, at least, so that you can track how much of the syllabus is done and how much is left. Is it clear?
Yes, sir.
Yes, sir.
Are you done, Mahi?
Yes, sir.
So why didn't you tell me that you are done?
So you
We
were
are
talking.
waiting. We we are waiting for you. Okay, so you write the heading reflection of sound. Yeah,
Okay, sir.
you write the heading reflection of sound. Done?
Yes,
Yes.
sir. Done.
Any sound is coming from your side. Okay, look here. We know there is one law for reflection. In this topic also we got that. In the topic light we also got. What is that law? Can you tell me the law of reflection?
Me?
Yeah, anyone you can say. Raise your hand and say. Yeah, Monica, say.
The incident ray, refracted ray, and the normal to the any interference of two given mediums all lie in same place,
Then,
and the ratio of sine and the angle of incidence or refraction is constant.
okay, so you are saying about refraction, right? So can you tell us about reflection, law of reflection? Because we are now doing reflection of sound, that's why you have to recall the idea of reflection now.
So the incident ray is the same as a refraction ray. I mean, reflected ray.
Yeah, actually, this is not ray. This is about angles, right?
Yes, reflected angle.
Yeah, write it first. You wrote the heading, right?
Yes, sir.
Then you write here, this is law of reflection, okay?
Okay, sir.
Here, this one you write, then write,
Angle of reflection.
and it is law of reflection, okay? Is law of reflection. And this law is uh, followed for all the waves. We got it in light, we got here also in water wave. Same way we are getting it for sound. Now we are having one experiment to understand that sound also follows this law of reflection. For this, we have two cardboard tubes. We have one source of sound. You see it's written here watch or buzzer. That means it is source of sound. And we have here one board from where the sound produced in this source that will be reflected back, returned back. Okay? If it is returning back, then you can hear it from here. If you stay here, then you can hear the sound. But if you are moving your place, uh, you are going other place rather than this, then you will not be hearing the sound. Is it clear to you?
Yes,
Hello.
sir.
Yes, sir.
So from this experiment, we understand that sound also follows law of reflection. So I want you to draw this diagram exactly the way it is.
Okay, sir.
Do it quickly. If you are done with this, then our this topic is over. We have only this learning outcome left. So, Monica, can you please take this diagram and send it to our group? Wait, Monica, little bit wait. I am drawing little bit than you send. Huh? Here I am drawing the normal, huh? That will make you understand more. Then you label here. This is I. Label here. This is R. So I and R. These two you also label here. These are equal. Then here you label. This is normal. Yes. Now you sent. Okay. So you see the diagram from the group, huh? Mahi?
Okay, sir. So I drew it already.
Yeah, you have done it. Very good. So we are now showing you the syllabus. Today we will analyze and we will show you how to analyze learning outcomes from the syllabus so that you can apply it for other topics, other subjects also. And look, today again I am uploading it for you so that you can get it easily. And you please download this syllabus. Download in your
Okay,
device
sir.
and you regularly check fortnightly or weekly your learning outcomes, your topics which are done, which are left. You have the book also, right? Textbook.
So which book?
You have any physics textbook?
Yes, sir, I do.
So any book you have, you go through the contents, then you'll understand, right?
Yes,
We
sir.
we actually follow the learning outcomes. So if you have any of the physics book, then it will help you to get the learning outcomes, right? You can
Yes,
get it
sir.
from there. Normally, we in Bangladesh we are following the book from Charles Chew, the book written by Charles Chew, that is a course for O-level physics. But there is another book that is written by Tom Duncan, IGCSE Physics. That one is more better. In my opinion, that one is better. Okay. So if you did not buy any book yet, so I prefer you to buy that one, Tom Duncan's one. I will show you the cover page of Tom Duncan now. Do you want to
Okay.
see? Do you want to see?
Yes, sir.
Okay, I'll show you then. First, I upload the worksheet, related worksheet now. Then I will upload the syllabus. You see, the worksheet on topic 13 I'm uploading. So it's already there in your Google Classroom, the worksheet. Now I'm uploading the syllabus. So you are the candidate of 22, right? Hello.
Yes, sir.
So I'm uploading
Yes, sir.
22 syllabus. From 23, the syllabus changed. Little bit changed. So here you go. We have all these things here. Now
Okay.
we are seeing the learning outcomes of this topic 13. This way you go. Always track your syllabus. Please follow it down. Yeah, just now we did this. Look, can you read the learning outcomes, Mahi? Read loudly.
Okay, sir. Describe what is meant by wave motion as illustrated by vibration in ropes and springs and by experiments using a ripple tank. Wavefront. Define the terms speed, frequency, wavelength, and amplitude, and recall and use the formula velocity equals to frequency times wavelength. Describe transverse and longitudinal waves in such a way as to illustrate the difference between them. Describe the use of a ripple tank to show number one, reflection at a plane surface, number two, refraction due to change of speed at constant frequency. Describes simple experiments to show the reflection of sound waves.
So now you understand that all these learning outcomes are done, right, from this topic.
Yes, sir.
So we are done with Cambridge syllabus, these learning outcomes. Then we have confidence, right? We are confident. Yes, if anything comes from here, we can answer, isn't it?
Yes, sir.
So we want to be confident learners, right? So that
Yes,
our
sir.
preparation is very good. So you join after 10 minutes, at 10
Okay.
o'clock. Allah Hafiz.
Okay.